Hi, I'm Ms Hearn. Let's get started. Find the following limit or state that it does not exist. It's the limit as h goes to 0 of the square root of 361 plus h minus 19 all divided by h. All right, so whenever we're calculating limits, what we'd really like to do is to be able to just plug in the value. But we can only do that when the function's actually defined. And in this case, that would give us a 0 in the denominator, so that's not going to work. But whenever you see that you have a binomial, remember by binomial I just mean two terms, and terms are things separated by a plus or minus. So this might not look like what you think of as a binomial, but since these two terms, the square root and the 19, are separated by subtraction, it can fit the pattern of a binomial. And since one of the terms has a square root, multiplying by the conjugate of that binomial can sometimes be helpful. So that's what I'm going to do. So remember, if you have a binomial a minus b, its conjugate is a plus b. And the reason why that's helpful to multiply by is because it fits the pattern of a difference of squares when you multiply it out. So in this case, we would have the square root of 361 plus h plus 19 is the conjugate. Conjugate is the same two terms, but with the opposite sign in the middle. And then we can't just multiply it because we want to, but what we can do is multiply by 1. So I'm going to multiply by that value over itself. So I'm not changing the value of the expression, just the way it appears. So now when we multiply these two numerators together, it's going to fit this pattern. So we're going to get this equal to the limit as h goes to 0 of, and then we're going to have the square root of 361 plus h squared minus 19 squared. That's our a squared minus b squared. All right, now this is all going to be over h times the square root of 361 plus h plus 19. And it's usually best to just leave that factored out like that. Don't distribute it through, because what we're hoping is that this h cancels out at some point. By the way, as I'm working, feel free to type any questions about the explanation into the comment section. Okay, so now we're going to simplify algebraically. So we have the limit as h goes to 0, and then we're going to have 361 plus h, the square root and the square cancel out, minus 19 squared is 361, and then in the denominator that stays the same. Okay, now 361 minus 361 is 0 equals the limit. And by the way, you see how I'm writing limit each time in each step? Okay, so we're going to have h over h times all of this stuff in the parentheses. And then we're going to say, oh, okay, well, we have a factor of h divides into a factor of h, so that leaves a factor of 1. So that means we have the limit as h goes to 0 of 1 over square root 361 plus h plus 19. And now if we were to try to plug in the h equals 0, we would not get undefined. So we can go ahead and do that. We don't need to write the limit anymore. I almost wrote it. But once you plug in, that's the step where you stop writing the limit. You're taking the limit by plugging in. So that's going to be 1 over 19 plus 19, or 1 over 38. I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video.